In this video, we're going to look at solving polynomial inequalities, and we're going to use a procedure called the sign chart. You can also solve algebraically, and I will post a video that gives you some information for doing that if you prefer. In order to use the sign chart, we're going to find the real zeros of a function either graphically or algebraically. These are called your critical values. Once we have those critical values, we're going to plot them on the number line, and we're going to create the sign chart. So taking a look at this polynomial here, we have 0.5. That's my leading coefficient. It's not going to give me a 0. I have x plus 3, which is going to give me a 0 at -3. So I'm going to plot that on my number line. I have x squared plus 1, which would give me imaginary zeros. So remember, we're only talking about real zeros here. And then I have x minus 4 squared, which is going to give me a 0 of positive 4. Once I have those numbers plotted on my number line, then what I'm going to do is I'm going to test each region of the chart to determine the sign of the value of that expression. So I'm going to choose a number that is less than -3, so maybe I'm going to choose -4. So I'm going to plug that into this expression. You can do that with your calculator, or you can do that just numerically. You can also graph it, and you can test it by doing second trace value. So when I plug -4 into this expression, that's going to give me a negative answer. When I plug in a value between -3 and -4, so in this case I'm just going to choose to test 0. When I test 0, I can see from the graph that I get a positive value, or we can plug this in again using your calculator or just doing it by hand. So this gives me a positive value here, and then I'm going to test a value after 4, so maybe I'm going to use the number 5. And again, I can look at the graph here, or I can plug that in either by hand or with my calculator, and I can see that this is also going to give me a positive value. So then I have my sign chart. Once I have that sign chart, now I can use that to answer the questions. So in this first question, it asked me to give answers where the polynomial is greater than 0, so I want the values where it's positive. So remember, I want this section here. This is just strictly greater than 0, so I'm not going to include the zeros. And then I want this section here. So I want to write that in my interval notation. So we're going to say this is from -3 to 4. We're not including those, so I'm going to use the parentheses. And then also the section from 4 to positive infinity. This next one asked me for greater than or equal to 0, so now I want everything from the -3 and including the -3 all the way over. I can include the 4, and I can go all the way to the right forever. So for this one, we can start at the -3 and go forever to the right. I'm going to include the -3, so I'm going to put the square bracket on there. And then this one says less than or equal to 0, so I'm going to include the -3 and then everything to the left of that. And I also need to include the 4. So when I write this, we're going to say from -infinity to the -3, I'm going to include the -3 and x equals 4. All right, so we'll take a look at another example here. This one, again, is in factored form, which makes it easy for us to find our zeros, although we can always graph that, whether it's in factored form or polynomial form, and find the zeros that way. So just kind of working algebraically here, I'm going to take this first factor, 2x plus 1 equals 0, and I'm going to get x equals -1/2. X minus 2 equals 0, so x equals 2, and then we have 2x minus 3 equals 0, so x equals 3/2. So remember, those are my critical values. So I'm going to make my sign chart. It doesn't matter on your sign chart if things are like spaced out accurately, as long as the numbers are in order from left to right. Then again, we're going to test values in each of these regions. Once you have the graph, sometimes it's easy enough to tell. If you have your graph on your calculator, remember you can do second trace value, or again, you can plug values in. However you want to do that is perfectly fine. So when I test the values less than -1, I'm going to get negative values. Sorry, less than -1/2, I'm going to get a negative value. When I test a number between -1/2 and 3/2, I'm going to get a positive answer. When I test values between 3/2 and 2, I'm going to get negative value again. And when I test numbers greater than 2, I'm going to get positive. So be careful here. Remember, this is going to be 1.5 and this is 2. So you're going to have to use some decimal values when you approximate there. Then I'm going to go back to my inequality, and I'm going to see that this says greater than or equal to 0. So again, greater than, I want the positive regions, and I'm going to include the zeros. So I want between these two numbers, and I'm going to include those two values, and then I want greater than the 2. And again, I'm going to include the 2 because of the or equal to there. So writing my answer in interval notation, I'm going to go from negative 1/2 to 3/2, square brackets, and then from 2 to infinity, square bracket on the 2. All right, in this example, we're starting with standard form. So we either would have to factor that, which looks like it would be a lot of work, or we can just graph this and get our zeros from the graph algebraically. From the graph, we should get that this is -1, this is 1.5, and this is 2. So again, I'm going to make my number line, put my critical values on it. So I have -1, 1.5, and 2. Then we're going to test values in each of those regions. So testing a value less than -1, I'm going to get a positive answer. Between -1 and 1.5, I'm also going to get a positive answer. Between 1.5 and 2, I'm going to get a negative answer. And then after 2, I'm going to get a positive answer. So I'm going to come back to my inequality and see that it's greater than or equal to 0. So I want all of these positive values, including the zeros. So I want going to the left forever. I'm going to include the -1. I want everything between -1 and 1.5, including the 1.5. I'm going to include the 2 and then greater than 2 as well. So when I write this into my interval notation, we're going to go negative infinity all the way over to the 1.5, and then from 2 to positive infinity.